In this video, we're going to determine the mass percent of protons, neutrons, and electrons from the given symbol. So first, we need some valuable information, which is going to be the mass of our protons, neutrons, and electrons. So the mass of our protons is going to be equal to 1.00073 AMUs for protons. Our neutrons are going to be equal to 1.0087 AMU per neutron. And finally, our electrons are going to be equal to 0.000549 AMU per electron. Now, we need an example. So let's use this example of 89/38 strontium. Now we need to determine the mass percent of each of our subatomic particles. So first, let's determine the number of each. So the mass of our protons is our most simple one because we know that's going to come from our atomic number, which is the lower number, this guy, 38. Because this doesn't have a charge associated with it, we're going to know that our electrons are also going to be equal to our protons, which is 38. Now for our neutrons, we know this comes from this upper number, this 89, but we need to subtract our number of protons. So 89 minus 38 is going to be equal to 51. So we have 51 neutrons. Now that we have each of our atomic particles, the number of each, and their masses, we can start to deduce their mass percent. So first, we need to determine the mass of this symbol. So the mass of our 89/38 strontium is going to be equal to the following equation. That's going to be our number of electrons multiplied by their mass plus the number of protons multiplied by their mass, finally, plus our number of neutrons times our mass of our neutrons. All right, now we can start to plug in this information. So our mass of 89/38 SR is going to be equal to our number of electrons. We determined that was 38 multiplied by their mass, which is 0.000549, plus our number of protons, which is also 38, times its mass, 1.0073, plus the mass of our neutrons. We determined that was 51 neutrons, times 1.0087. So we multiply those together and add them up. This is going to come out to 89.76 AMU. All right, now we have our mass of our strontium. Using that, we can now determine the mass percent of each of our subatomic particles. So for our mass percent of electrons, that is going to be equal to our mass of our electrons divided by our total mass of our 89/38 strontium. So that is going to be equal to our number of electrons. So essentially we're going to be taking this piece of information here. We're going to be plugging it in down here. That's going to be 38 times 0.000549, all divided by our mass, which we just found, which was 89.76. Then we need to multiply this by 100 because we're doing 8%. And this is going to come out to, after we plus into our calculator, 0.023%. Now let's move on to our protons and then our neutrons. So our mass percent of our protons, same formula. Now it's going to be mass of our protons divided by our total mass of 8938 strontium. So in this case, we're going to be stealing this piece of information here. We're going to slip it right through to there. This is going to be, again, 38, but this time the mass of our protons, which we got from up above, 1.0073, divided by our total mass, which is 89.76, again, times 100%. And that's going to come out to 42.6%. Now, finally, we can do our neutrons. So the mass percent of our neutrons is going to be using the same formula, except now with neutrons, divided by the mass of our isotope, 8938 SR. So we're going to steal that last piece of information, this guy, this 51. It's going to snake right on through to the bottom. So 51 times 1.0087. All of that divided by 89.76 times 100%. And that is going to give us 57.3%. Now, one thing that we can do to check to make sure all of this makes sense is to add up each of our percents. We'll add this one plus this one plus this one. And it should come out to about 100%. If it's 99.9%, 99.8%, that's okay, because we're rounding these percents from these numbers. So if we take so let's check our total percent. Again, this should be close to 100, 99.9, 99.8, both are acceptable. So we're going to take our 57.3% plus our 42.6% plus our 0.023%. If we add all those together, this comes out to 99.9%. And that's close enough because we know that we're doing rounding in our percents. So from here, we were able to determine our mass percent of our electrons, which is equal to 0.023%, the mass of our protons, which is equal to 42.6%, and finally the mass of our neutrons, which is equal to 57.3%.